This is me and my COVID. So
That's a great background.
Yeah.
What did it say?
with the
Okay.
with Bob in the background.
Okay, thanks.
Yes.
There's some sort of cardboard box in your background as well.
That my COVID junkoscope.
Yeah, that's his square tube.
Really?
When I made my first telescope mirror back in 1960, it was an 8-inch f5, and I made a tube for it out of plywood, and it was a square tube. It was tough to lift.
Oh,
How thick was the plywood?
Probably a 1/2 inch. It was whatever was available.
2x4s in the corners.
No, I had 2x2s in the corners. I ripped a 2x4 down the middle, 2 of them.
Oh, yeah. 3 more people coming in.
I came in.
Yeah.
Hello, Gary. Chuck,
Chuck.
Bob, FL. Hello,
Did Vic come in?
Who?
Mr. Cottam.
Oh, guy from last week.
Raphael.
Hi.
Hello.
Vic,
So Raphael, are you still working at the museum in some capacity, or?
Yep. And I'm here both because I miss going to the meetings a year ago, and because I am the museum for now.
Okay.
I've been sent, you may say.
Wait, sorry.
Oh, did Charlotte want you to participate?
Charlotte wishes she could participate. She also may be joining us later, but I did express interest in coming to these since I thought that we weren't holding monthly meetings anymore, and it turns out we're not, but now it's weekly. But I wanted to come anyways, so we just decided that we'd do it.
Great. What do you do at the museum right now?
Can you hear me all right, first of all?
Yes.
Yeah.
Okay. Well, at the museum, I do the same thing, but I also teach a couple of virtual classes. As of yet, I host classes that have to do with astronomy, but co-host a variety of other classes or virtual programs. And I'm setting up an astronomy table at the museum about 1 to 2 days a week. But
What does hosting a class mean as opposed to teaching a class?
well, when you host a class, you are the presenter for the material. And when you co-host the class, you are support. And you offer any, help with the kids, help with something like that. And the classes are for elementary school to late high school.
Okay. Thank you.
So big news about the Baron.
Yeah.
Yeah.
Yes, the radio shows are off the air. The Baron retired.
What?
My
Sorry.
screen is completely blank here. Wait a minute.
Still see you.
Okay. There we are. I got some pop-up thing. The Baron, there was a new reporter, staff reporter, or writer for the newspaper, the News Press. And the writing wasn't terribly good, but Baron wrote an email to her and welcomed her to the staff and was very friendly and complimentary of her. And at the end, he put a PS in, and he said, by the way, when you put in an acronym, you need to explain what the acronym is in the first, right up at the lead part of the article, which in my view is SOP, Standard Operating Procedure. There, I do it too. And then he also pointed out that she persisted in using the same word, COVID, all throughout the discussion, and it's traditional to shift it from like COVID to the pandemic to illness or something, or a pronoun. And so he meant that in the most helpful way. She complained to her boss, who took it to Wendy McCall.
Okay.
And Wendy came down to the Baron's boss and said, we're not going to hear any of this. You keep your mouth shut about criticizing people. And so that was Friday. And over the weekend, Baron cleared out his desk and everything because he was insulted and didn't like the approach. And so he sent an email on Monday morning after he finished his morning programs. He said, I'm out of here. I'm retired. Goodbye. And he waited to see if they would say, no, don't leave. We'll apologize. And they didn't. They just said, be sure and leave the key. And so he's out of there. And he says he feels real free about it. So I've been talking with our webmaster about doing the radio shows on a continuing basis, but not doing them on the radio, but doing them as a, what is it again?
Podcast.
Podcast, thank you. I keep mixing it up with blog, but podcast. We already have a SBAU website run by Ruben, which we do not intend to take away from him. But there are.
Well, he just does Facebook.
What's that?
He just does
on
Facebook. Yeah.
That's correct, Facebook. And so we can do that on, and I guess the webmaster has a YouTube account or something on there. So there are many other things that I've heard about, but being my generation, I would rely on my teenage children to explain it all to me, but they have now graduated on into their lives and are married and having kids and stuff. So I've got to figure it out for myself. But it seems to me that in this modern age of technology, we can proceed with a radio show, but not with the radio company. And it could be an official organization of the SBAU supported by that. Or if we do our marketing correctly, we could get the museum to possibly support it. But then we would expand the format of it to not be just about astronomy, but also about museum events and stuff. So these are initial thoughts. Nothing's being pushed here. We're just in discussions to see what's possible. So you've all heard it here first.
Very good.
Okay.
I was afraid it was my Trump joke.
With Trump jokes, he didn't mention that specifically, no, but I think, and Wendy didn't either. But he's actually, I don't want this to go any further, but he's relieved that he's not working for people that are of that political persuasion. Mm-hmm. So the Trump jokes wouldn't have offended the Baron. So anyway, back to our charter of the telescopes. If you don't mind, there's a couple of charts I'd like to show you first off.
Okay.
If I can find them. If I can't, I'll give up until next time. But let's see.
If people turn on your chats, you can see I put some comments down that Rob Matson had some comments and a question at the end. So take a look at your chat. It's a long comment. So Rob, I hope that's okay. And,
okay.
Yeah, that's fine.
If you'll look at, can you share my screen now?
Yeah, you can just click on share screen at the bottom and then click the window that you want to share.
Okay.
People can share.
It should pop up with a little windows that you have to choose. Yeah.
Some questions have come up last week, and I want to talk about just real briefly about nomenclature, because there's a trick here when we talk about images, and if you're a technical background, noise has a very specific meaning to it. And when you speak colloquially, and most astro imagers are using colloquial terms, but a lot of the algorithms that we use are based on engineering, and they use the technical term. And this refers to the word noise. And so I have my chart here of noise, not noise, and guitars. The two definitions of noise physics, noise is specifically a stochastic temporal fluctuation in the signal amount of mean value. Noise is not something by itself. It is a random fluctuation of something. But colloquially, it means like if you're trying to take a nap on your couch and the neighbor next door has a new guitar and he's not very good at it, then you would consider no matter what sound comes from him as noise. And that's basically an unwanted signal, AKA Jeremy's new guitar. So we talk about, when we do images, we talk about spatial noise, which is an oxymoron, because spatial noise is also known as fixed pattern noise. And it's like Pluto being a dwarf planet. It's not a planet, it's a dwarf planet. It's not a planet that's a dwarf. And so fixed pattern is the opposite of a noise, but it looks like noise. And so many parts of the definition, but not all of them, satisfy that. But it does look kind of like noise. So we refer to it, and everybody knows what we do by calling it noise. But it is not noise. And the next chart, if I can find it. Is that unwanted signal can be reduced by subtraction. For example, when we see a background that fluctuates, fixed pattern noise, we see hot elements and cold elements, and we see a fluctuation of what should be a uniform background.
Jerry, we're not seeing a chart there.
Okay.
We're seeing a fixed pattern.
We're seeing some noise.
Your screen sharing is paused.
What does stochastic mean anyway?
Stochastic means random in time. So, okay, how about now?
There you go.
Okay. Yes. Unwanted noise can be reduced by subtraction. Unwanted signal, excuse me, can be reduced by subtraction or by replacement algorithms. That means that if you have a dark frame, you can subtract it from the frame you took and it will remove the fixed pattern noise. Or you can use a pixel map and you can reject every outlier and you can replace it by an average in 2 dimensions of its nearest neighbors. Now that, you can't do that with noise. You can only do that with an unwanted signal. Noise can only be reduced by adding more noise in. And noise, a more noisy signal, when you add a signal that has noise in it, the signal increases by, if you add 2 of them, 2 frames, the noise, the signal goes up by a factor of 2, but the noise goes up by the square root of the sum of the 2. So you gain on the signal to noise ratio by adding in more noisy signal. And so eventually when you renormalize it, the signal to noise improves and it looks like the noise is reduced. So that's the only way you can get rid of real noise. And that's buried in some of our algorithms. So when you take a dark frame of your camera focal plane, that is a frame that never changes. That is, hot pixels are always hot pixels. Dark frames, underperformers are always underperformers. It's a variation in responsivity or in conductance or resistance of the focal plane diodes. So, but on top of that, if you look real close at the signal, say a bright pixel, you will see that value in time fluctuates very slightly, but it's not the most notable effect. But that's
Jerry,
yeah.
Did you want to show a different slide? So I'm still looking at the key difference slide.
Yeah, no, I don't have another. I've tried to find one that covers it better. You see this slide?
Yeah.
Okay. This is the signal chain of our detectors. Although where I did it, we did it in infrared. The scene comes in with a flux that comes in, photons per square centimeter per second, and it goes through the detector, and it has in it a noise, which is we refer to as a noise generator, because there's fluctuations in the number of photons that hit every second or so, that it moves around a bit. Sometimes a lot are hitting and sometimes a few are hitting. So that's real noise. And that's the photon noise that comes in. Then there's photon noise or photon signal that comes through. But now the detector also generates its own dark signal. And that's where you get, that signal is really that is the dark frame. That's the values of the dark frame. That dark frame noise, that dark frame has a noise, which is called the detector noise on it. But the dark frame variation is not the noise. And the photon noise and the eye detector, the detector noise, these add by adding a root sum square. The photon noise and the dark noise simply add. The readout is for this case is a transimpedance amplifier. So you get a current in and a voltage out. So you get the photon noise out as a voltage, the dark noise out, excuse me, you get the photon signal out as a voltage, the dark signal out, and now you've added in a new signal, which is the readout integrated circuit for each channel. And on top of each of those, you now have a photon noise, a detector noise, and a readout noise. And then that goes into the, what is that, analog signal processor and downstream and stuff. So you have different ways of treating these things. You take the noise out by adding frames, subframe, because it averages out the noise. But you take unwanted signals out by getting a map of the dark current or dark voltage at this point, and the readout current. This is the bias frame. And so you subtract those out from the signal you get, and that just gives you the image of what you want to take a picture of. But the noises you have to treat differently by adding in noise, by doing the subframe averaging. That's all I wanted to say. Just there's a nomenclature difference, and it doesn't really matter very much what you call noise or not. But if you look at the things that are written or algorithm, for example, in CCD Stack, they have a wonderful series of help pages to walk you through each stage of their algorithm. And there they strictly use the physics definition of noise. If you come in there with a colloquial definition of noise, you're going to get confused. And from my years of tutoring and teaching physics, I found that one of the reasons that some students consider physics to be hard is that physics, like a lot of disciplines, they take words out of colloquial speech, but they give a new and very specific meaning to it. And if you sit in a physics lecture and you try to understand the physics lecture based on a colloquial meaning of words such as work and force and stuff, you're going to get mighty confused. So I just wanted to lay this out there for people. If you have any more questions, I can go over it with you in detail. Thank you.
The detector, no, the detector noise, that's like the Poisson noise distribution, correct?
Yeah. Yes. Whoops. Oh, there I am. Okay, good, I'm back. Okay. Sorry.
So
Yeah, when you're
Rob,
talking about the noise associated with the signal, just the random arrival times of photons
Right.
during your integration time, the other name that's given to that, you know, again, speaking to your jargon that comes up in physics, is shot noise.
That's correct, yes. Actually, shot noise was, you're right, that's what shot noise is, but shot noise was originated back in the day in the 30s when they had diodes that were vacuum tubes, and they were sending electrons from the cathode to the anode, and the arrival time of the electrons in that case, and they listened to it and it sounded like someone dropping BBs or buckshot onto a piece of tin. and that's where it got the name.
I always wondered if it was what the etymology or the origin of the word was.
Mhm. So if you ever get shot by a buckshot, you can note the different arrival times of the different pieces of shot.
Not good for your optics.
No, no, no. So anyway, I think Gary had some questions, and someone else had something they wanted to say. I remember from the email.
In the chat, Rob, I put Rob's email to Bob and I about something which I haven't really had a chance to read yet. So Rob, we go over that after Gary asks his questions.
Gary.
I'm not seeing it in my chat.
I didn't see it either.
Oh, maybe because you came in after I posted it, perhaps.
Oh, maybe.
Maybe I can send it as
Is
a
it about
file.
the thing about pixel
my
size
chat's
and
blank. It got erased.
Let's see. See if I
I'm going
can
to take a
find
short bathroom break. I'll be right back.
it. And Bob has a diagram to go over as well. A bit. Let me see.
I can tell a bit about my mishap
Okay.
if I can share the screen. Let me see here. Let's see. Yeah, I guess share. Should work. All right. So as some of you know, that I've modified my Fuji for astrophotography, and I was pretty happy with it, but I did get some gradients once in a while, and
Oh, yeah.
so there was a strong gradient from the upper left that was the Horsehead only, but for other targets, I also had a gradient from the lower left, and that seemed to be always coming from the lower left. So last week, I took one night where I imaged 4 targets, and this is the beehive, and clear enough, the gradient is there. So, and then I went on to the
That looks like the amplifier heat noise that you get on the Malin cam.
Oh, yeah. So actually, I got rid of it. This is in M67. So I had some good practice in GIMP. I practiced with linear gradients. So this is with the gradient removed. That sort of works. You know, you remove some of the nebulosity. This is the Seagull nebula, also gradient in the lower left. And if I remove it in GIMP, I get this. I mean, it's not totally destroyed. I'll revisit that target some other time. And this is a skull and bones. Never heard of before. This was with gradient, and this is with the gradient removed. Anyway, so long story short, I decided it was my camera, so I opened it up again, and here it is. Unfortunately, the patient did not survive the surgery. So everything went pretty much okay, and I put it back together again, but in the end there was so I had put the battery in, tried it, nothing happened. So I opened it up. I noticed that there were a few ribbon cables that were loose, and I tightened those. And then I thought I got it, but meanwhile, by all the moving around, there was the ribbon cable from the LCD had a slight tear, and it flashed the screen one time and one time again, and then it went dead. So that was that. That was the end of my Fuji. So. It wasn't. Yeah. Anyway, it's not a big deal. I'm waiting for my AC 2600 mm, and I will probably. I mean, it's a lot of work to get that. I was pretty good at opening it up. This was in an hour or so, and here's the sensor somewhere. Yeah, so that thing over there, that's the sensor, and there's a piece of glass that goes in front of it. So before you modify it, there's first this piece of glass, then underneath there is the infrared filter, then comes the sensor. And there was also some glass that I had broken the first time, because that piece of infrared glass didn't come off easily. It was stuck under a plastic clip, and I had to use a screwdriver to pry it out. So it caused some glass shards, and I could see that in my flats actually. Anyway, I still have another Fuji, the same kind. That does work, so it's not that I can't do anything anymore. All right, well, that's what I had to share.
That was fun.
Yeah, I still have a Canon. I think I can. I have an old Canon 450D that I haven't, that I'm not using anymore because I got a new T6 at Costco. It was only like $450 with 2 beautiful zoom lenses. So I can modify that one. And that's one that can be controlled remotely, actually. The Fuji could not. And that was...
Why couldn't the Fuji be modified?
The Fuji was modified. What do you mean by... Yeah.
I thought you just said you couldn't do it.
No, remote.
Control it
Controlling
remotely.
it remotely.
Oh, remote
So you
control.
can
Yeah.
control it from a
apologies.
USB port.
Yeah.
I want to use it for ecos that I use for astro imaging, and they support G-Photo. So G-Photo is one of the Linux things that supports all kinds of. Fuji XA series is not on the list. XT is on it, but they're much more expensive. I mean, I don't want to pay more than $100 for a camera. So, but
So-
yeah.
Did Gary have a question?
Yeah, excuse me, I do. I have 2 Televue telescopes on Televue mounts, Televue eyepieces, everything's Televue. But just, I try to, well, I also have a Japanese,
Takahashi.
yeah, Takahashi finder scope, and with a star beam. So my Genesis, my 4-inch Genesis has 2 ways of finding my target, red dot finder and Takahashi, but I can't get. I don't quite understand when you try to adjust your view, your finder scope. What the hell are all those screws for? You know, I mean, I don't know. You tighten this screw or it does nothing. You tighten this screw, it does something. I'm trying to get it even so that I can see the star beam and the star in the same telescope.
Well, you should have I think the finder scope should be mounted with 6 screws.
Yeah, it is.
3 in the other, and then 3 in the front and 3 in the back. And
Yeah.
those, if everything else is tightened down, then those are the only 6 that you have to worry about to get it pointed right. And so if you lock down the front 3 and just work on the back 3, that should let you, move the scope around until it points at the target. So you set your main telescope up on some target. I use a telephone tower or a TV broadcasting tower that's probably about 20 miles away on the top of the mountain. And I set the main scope on that. And then I true in the finder scope with the set of 3 screws in the back of the finder scope.
Oh, you use the ones in the back to do the adjustment?
Because they're closer to where I'm looking.
Oh.
If I had for a refractor, I use the 3 in the back.
Yeah, that makes sense.
And I have the 3 in the front snugged up so they won't move.
Oh, yeah, okay, that's a big help.
Yeah.
Also, both of my telescopes have this problem. If I use a 2-inch eyepiece on my Genesis, chances are when I let go of the tube, it's going to move.
It's going to what? When you put the 2-inch eyepiece, it's too much weight and it moves?
Yeah, it's like there's only a small range of eyepieces that I can keep it balanced without tightening down the
screws.
Top. I mean the bearing down.
The clutch.
Huh?
Yeah, the clutch. You got to tighten up
Yeah.
the clutch. And if you don't want to do that, then you've got to find something that balances that eyepiece. And when you put that eyepiece in, you put a beanbag on the front of your telescope or something.
Yeah. Does anybody else have that problem?
Can you slide your refractor back and forth to
Yeah.
balance it a little bit better?
Yeah. It seems like, well, to put a 2-inch eyepiece on a Pronto is pretty difficult to.
Pronto's a 70 millimeter diameter.
Yeah, it's a very small test.
Very small.
I don't know, I was sort of trying to find different ways of balancing the tube to one adjustment suits all, you know, but
Didn't you buy a solid brass
On
insert
a,
for the, so that when you're 2 inches out, the smaller eyepieces weigh almost as much as the 2-inch?
oh, the equalizer.
Yeah,
Yeah, I have an equalizer and it does help
okay.
with when you shift from,
Yeah, I don't know anything beyond that, the equalizer or putting a beanbag on the front that would help.
those clutches on the Televue telescope are
The mount.
they're not that effective.
or you
Yeah.
could have a sliding counterweight that moves up and down to
Yeah, I don't
compensate.
have that. Can you get something like that? How would I attach it?
Like bean bags.
Yeah,
I was thinking of Velcro.
Yeah.
that would work too, Velcro weights.
Thursday.
Yeah, isn't it? But isn't that strange? Is that the Televue makes it this way? So you practically have to use pliers to turn that clutch.
Oh, to get it tight, yeah.
Or to get it loose, and that's not good for the bearings, you know.
No,
You can feel like a bump.
thank you.
So Gary, is that a German equatorial mount, the Takahashi?
Oh,
Televue mount?
it's all Televue mounts. The Takahashi is on
It's
top
an
of
out as Televue mount.
It's an Alt S.
Yeah,
So is it moved with motors or is it manually moved?
No, it's just me.
Just okay.
it's a push to.
Yeah. Sort of. I think I'm kind of Lone Ranger and using these alt as. When I started doing astronomy, that was the main thing, wasn't it, Jerry? 30 years ago, 20 years ago?
It's what, alt as?
Yeah.
Well, some people, it's intuitive to use an alt as, but all the time I've been involved in it from 1960 to now, I've always used equatorial German mounts.
Mm-hmm. Okay. Well, thanks for your suggestions.
Sure, good luck.
Ideas. Thank you.
All right. Let's see. Okay, Rob, you might have the floor here. I attached a text message to the chat box, and I don't know if you can click on that text message, you know, just in normal text, and take a look at it. So if you click on chat, and if you click on the file I attached there, it might open up and show Rob's comments and question.
Yeah, it's still not showing for me, but it's okay. I can summarize kind of what I was the train of thought that was going through my head. As you know from my last couple of weeks of joining your club, the struggle for me has been of figuring out what I wanted to do in terms of a telescope camera combination that would achieve, you know, my goal, which was dim target detection. At least that's one of my goals. And I found myself, you know, buying into the hype about how important F number is, and it's like, oh, you need to have, you know, the faster the system, the better. But really, that's misleading because it's coming from the photography world where, you know, F number changes actually alter the aperture, whereas in astronomy, you're not altering your aperture. You may be choosing your focal length, but you're still collecting the same number of photons. So, you know, a light bucket is a light bucket, and there's no magic bullet where you say, oh, well, I have an F10 system, but boy, if I put this Hyperstar from Starizona on the front end of my Celestron 11 inch, then I can go down to f1.9 and I'll be able to see things I couldn't see before. It's like, that's not the case.
Yeah. Let me make a comment that you're correct, I think, in the fact that when you change from a camera to a telescope, you're not changing the aperture. But F number acts just pretty much the same way. If I go out in my backyard with a 10-inch f5 and I take a picture of something like the Crab Nebula, then any other scope at f5 will give the same density of image of the Crab Nebula. For example, the 200-inch, the 100-inch telescope is an f5 up on Mount Wilson. And it would give the same density of image of the Crab Nebula as my 10-inch f5. But of course, the image would be much, much, much bigger on the 100-inch telescope. But the density of image would be the same. So it's your aperture collects the same amount of light at any f number, but the shorter the f number is, the smaller the area it has to spread that light over to make an image.
Right. So I guess what I was
getting
at,
more signal into each pixel.
Right.
Yeah.
But if you are in the position of designing your system and you are marrying a particular pixel pitch to the f number of whatever telescope that you're going to insert that into, those two work hand in hand.
Right.
The sensitivity of the system is inversely proportional to the square of the f number, but it's also proportional to the area of the pixel. So that means it's proportional to your IFOV squared. So those two work hand in hand. You can double the pitch of your pixel, and that's the same effect as dropping the f number by a factor of 2. And so what ends up happening when if you have a small, modest aperture of 11 inches, an f1.9 that Hyperstar is going to give you is going to be a very hard system to marry to pixels, because in order to get proper sampling of your point spread function, you're gonna need pixels that are smaller than 2 microns. And so what ends up happening is you're struggling to meet your requirements because you've chosen an acceptance cone at your particular f number that makes it very difficult for you to choose the correct, or even to buy a focal plane that matches it. At f10, it's a lot easier to find a pixel pitch that's going to work for you. And I guess that was that kind of epiphany about don't get hung up on f number, because as long as you choose your pixel scale to be appropriate to your level, whatever your astronomical seeing is, you're going to be fine.
How do you determine propriety of pixel size? What are you using as a criteria?
Well, I'm saying the manufacturer of individual cameras will tell you what the pixel pitch is. Right.
But you
say, oh, there's 3 microns or 6 microns or whatever.
I think I'm hearing you want the pixel pitch to match the airy disk of the point spread function in your telescope.
I thought I've got
right.
a document up, so I thought I'd just share this so you guys can look at it if you want.
Oh yeah, so this was just an example calculation of what pitch I was going to need for an 11-inch with Hyperstar on the front of the Celestron, and I was gonna need 1.29 micron pixels, which is not obtainable.
Yeah.
So
if you want to sample a certain way, then you're limited. Then you have to fit that together as a pair. But I don't see anything wrong with oversampling. That is, having pixels that are way smaller than your resolution element of the telescope.
Yeah, you want to do that. Right. I would say at a minimum you would want to do 2 times oversampling of your airy disk.
Yeah.
And as I point out in this little diatribe of an email, the purists are saying you want 3.5 times sampling of that airy disk. I think that's overkill in terms of you have such a low energy on detector when you do that, that most of the gains that you get from oversampling occur by the time you've done 2x oversampling.
It's true that
How would a Barlow affect all this if you put a Barlow in?
that makes the F number longer.
Yeah, that allows you to have greater oversampling if you kept the pixel pitch the same. So one of the things that I did was just investigate, the most successful telescopes that are out there for asteroid discovery, for instance. It gives me a measure of what their true sensitivity is. Now, of course, a whole bunch of factors, affect, how well a certain site is going to do, but they all have the same problem. They want to try to do a decent match of the point spread function that they regularly achieve with the choice of the camera that they've got attached. So yeah, if you're at Haleakala, you've got incredibly good seeing. Much of the time, you're half a arc second or better, and so you would want to size your pixels accordingly to take advantage of those times where you have great seeing. And then on the times that you have crappy seeing, you can always bin your pixels.
Now, binning, I've never understood. I've heard it said that binning lets you take a picture faster because, say, if you bin 2 by 2, then your detector area is 4 times the area of the previous case. And so you're collecting 4 times as much light per second. And that's true, but you're also distributing it to a capacitor that's 4 times bigger. So it takes the same length of time to fill the capacitor's storage well half full as it does with the smaller capacitor and therefore detector. You see what I mean?
Yeah, binning definitely helps in the sense that if a point spread, it gives you a more dynamic range.
That's what I disagree with. I don't see that. Maybe you can enlighten me. But the binning makes your resolution element bigger, and it undersamples the detector or the star. And you want to stay away from that from one reason, and that is you don't want a star to look like a hot pixel because you have a lot of algorithms that reject hot pixels, and you don't want them to reject faint stars. So
no, you've hit on the crux of the matter is you cannot have 100% EOD or even 80% energy on detector because it makes a dim target indistinguishable from a hot pixel.
Right.
And so you have no means of positively identifying it, or you can't take advantage of we call it pulse matching. Where you can gain some signal to noise by the expectation of what a signal should look like, whereas an artifact such as a hot pixel or a dead pixel will make it. Yeah, it'll be.
I get the idea, right?
Yeah, you know what I'm talking about. You want to take advantage of the fact that a true star or a true target that's unresolved is going to have a shape to it. Right. It's not going to be just boom, 1 pixel. And if you have pixels that are too large, like you just aren't sampling your blur very well, then you can't distinguish. That's why they want you to oversample.
Yeah, the Nyquist limit, I think, gives you two samples per dimension across the star. So a total of 4 detectors detect the star. And I always go bigger than that, more detector elements. I like to oversample a lot. So
yeah, people that want like round-looking stars typically will go with considerable oversampling in order to achieve that, at the expense of a little bit, you'll get a loss in you're going to need a much bigger focal plane array in order to cover your field of view once you've made your pixels so tiny.
But isn't it with the smaller pixels, even if you're oversampled a little bit, you might get a little bit more accuracy in the location of the half maximum width of the star. If you're exactly on the pixel, you could be, well, you're limited by the pixel resolution. Another thing
we
I
call
was
it
thinking is the fact that if you try and go to a camera with too small pixels, then all of a sudden you're losing your full well capacity of your pixel, and therefore the dynamic range. So you've got to weigh those two things together.
Yeah, those work against you. If all in a perfect world where you had as big of a focal plane as you wanted, you'd say, oh, I'll just make the pixels as tiny as possible. The problem is that capacity is kind of linearly related to the area of the pixel. So tiny pixels have low dynamic range because I can say I've got 1 electron or I've got 20,000 electrons, and I can't do any better than that, or I'm going to saturate.
Mhm.
So
And that's the problem. Is like you get down to these sub 5 micron, 4 micron, 3 micron cameras. You'll notice if you look at the manufacturer specs that the full weld is correspondingly falling unless you have a very expensive camera.
You have to do a much shorter exposure time, otherwise you saturate that small pixel.
So
right. So then you end up just doing lots of stacking, which answers back to your your original point about knocking the noise down by a square root of the number of samples you take.
Rob, I see that you write whether 11-inch scope is f10 or f1.9, you don't magically change the number of photoelectrons collected per unit time. Actually, you do, because you only have a finite size of your sensor. And so if you image at f1.9, you have a much higher concentration of photons on your sensor. There's going to be a whole lot more photons on your sensor. And that's especially for DSOs, if that's your goal, it's important to have a very low F ratio number.
That's only true for a fixed pixel size. If you have the ability to alter your pixel size accordingly, then the F number it's something that trades with pixel pitch.
Okay, so I'm just thinking in terms of the numbers of photons per square area. How you combine them in pixels, I don't know what you mean by changing the pixel pitch. It seems, I thought a sensor was a fixed thing with a fixed pixel size.
It is, but you would choose the camera that best matches the choice of F number.
Okay, sure, yeah. Now, I'm just thinking about a fixed pixel size, but okay, but even if the pixel pitch changes, you can have small pixels that receive a lot of noise, and then you can bin them if you like, and then you end up probably with something similar as if you have larger pixels. So I'm not sure if that's an argument to say that the F number does not matter. It matters big time. If you start doing astrophotography of dim objects, you want a good F ratio, you want a fast scope, because otherwise you'll be waiting a lot longer. Now, if you're doing asteroids and resolution is important, then I'm not sure if that's the same criterion. But,
no, there's definitely a difference between when you care about extended sources, which is I'm sure what most of you are interested in AP. It's when you're doing point source detection that it becomes irrelevant. So for me, I have to balance those two wishes. I want a system that performs well against wide field objects, but at the same time, I want to be able to have good limiting magnitude detection, and that's what's driving.
That's your aperture.
Right, and it's all, and then it just becomes a light bucket issue. I gave the example to Bob that consider Hubble. Hubble is f24.
Oh, I didn't know that. It's a compound telescope. So it must.
Now, granted, they've got the benefit of no atmosphere and they can integrate for as long as they want. But there are limits, of course. You know,
Right.
your dark current
Now for us,
rises linearly with time. So you eat up all your dynamic range if you integrate too long.
yes.
Just a little side
For
thing.
us, ironically, if you have a slow system, a higher F number, say F9 instead of F5, the sky glow in the background, you can gain an advantage over that because it spreads that out. And so you can get ahead of it in the faint object you're looking at.
That's one of the other things that I was kind of struggling with
But yeah,
with Hyperstar is that, I've been reading about how people have a pretty difficult time maintaining focus. When you're at you're
yeah,
sub F2, you have a very, very tight focus range.
right. It's not forgiving.
No, yeah, you don't have a lot of slop, and you
want the
probably
carbon
would have to, you would have to dynamically adjust focus, during long exposures to maintain that, because probably temperature changes alone, during a long exposure would foul your focus.
What are the tubes of, say, a Celestron made out of? Is that a metal or is fiberglass or something?
They have carbon fiber tubes, but they also have metal tubes.
Okay.
Yeah, I have an old carbon fiber GPS 11. So
Okay.
And do they vent those tubes now? I mean, even though, an SC is by nature a closed system, they recognize that, a lot of the distortion that you're going to get from, air currents, from just thermal, there's a name for the convection, will affect a closed system. And so I think they've started to vent those, right? They have like a vent on the back.
Off the edge.
Yeah, they got
For a while had a fan, a little fan that they put in them.
Yeah.
But I haven't
And do
looked
they blow
closely.
like a transverse across the primary?
I think
Yeah,
they
yeah.
were just behind the cell.
Talking about the rod or the
No, it was a fan to circulate air
inside the tube?
inside.
Yeah, the
Yeah.
edge.
I would admit that I was also a little bit nervous about the going back and forth between using the secondary of a Celestron Schmidt cast and then popping it out and putting in a the Starizona transfer optics and a camera and so forth at the prime focus. I always worried about, it's like, how am I gonna align this thing every time I want to change it out?
It also caused problems. I know Bob isn't here tonight, Bob Richard, but you have, especially he was putting a DSLR on his Hyperstar system, and the lever.
Yeah, it's like
arm,
putting your head down and blocking half the light.
yeah, but the lever arm on that system made it real easy to crack the corrector plate.
Ooh. Yeah, I wondered if there was some limit to the amount of weight you could put.
Yeah.
Yeah. Or I don't know how rigid those materials are, but you're going to start, altering the refractive properties of your corrector plate.
Yeah, I think those plates are pretty thin. But anyway, I don't know. I never owned one of those.
Anyway, on the plus side, it allowed me to open up my telescope options and not be so married to the idea of getting a super fast Celestron or something that could act like a RASA scope, but not be permanently such. Because I did want to be able to look through the thing, and obviously an RASA scope, that option goes away.
What's a RASA scope? RASA? What do you mean? By that?
Roe Ackerman?
Yeah.
It's a design that, the focal plane is where the corrector plate is.
Oh, okay. Then
So you can't obviously look through the system.
Yeah. Huh.
But for
The
people
focal
that,
ratio, I mean, the focal ratio of it's a longer scope than your normal SCT also, and heavier.
I think it's a solution that's used a lot for robotic telescopes, where you just have some remote observatory and you're commanding it, so you don't need to worry about an observer being able to look through an eyepiece or anything. You've dedicated a camera to it. But I also worried about, well, how am I going to do a filter wheel where the camera is in the field of view, and just starting to really eat into the light bucket by having all these extraneous items in the field of view or blocking the light.
You have to go for a 14-inch.
There you go. Just go bigger.
Bigger.
The new RASAs actually have a way of attaching a filter in front of the camera. They screw in. You don't have a filter wheel, obviously.
How do you change
But
filters
that's a little bit,
exposures then?
slow.
How do you change filters between
Pardon?
exposures?
Yes.
Makes it tough to be a robotic
But,
scope.
but if you're doing asteroid search, what do you need filters for other than possibly?
Oh no,
light
yeah,
pollution?
I would want as much open aperture as possible, and particularly at the red end, which is most asteroids are red heavy.
Oh, I didn't know
So, but if I wanted to do astrophotography, I would want to be able to go multispectral, and that's where I was like, oh, I'm not going to be able to do that at the prime focus, swapping filters in and out. I'd have to manually do it because there's no physical space to put in a filter wheel.
Well, you need
Why are they red heavy?
You need a Newtonian astrograph then. Everything's off to the side.
I was going to.
Oh, just like with the pick-off mirror?
Yeah, secondary. Yeah, flat secondary.
Why are asteroids red heavy?
The minerals on the surface.
They all have the same minerals on the surface?
No, but they tend to be red.
It's just, their reflectivity favors longer wavelengths. So you're good if you can go out into the near IR, because the reflectivity is fairly flat from red out into the near IR.
Yeah, so if they rotate, they don't change as much in the red wavelengths.
So your silicon detectors are red sensitive. So if you had a non-color,
Is that red? Does that red result from the
it would be more red
environment
sensitive.
the asteroid is exposed to?
I think it's the weathering of the surface. Something that's been up there orbiting the solar system for 5 billion years is pretty dust covered.
Okay.
So is it time to change over to Bob Gruenberg? Did you have a diagram you want to show, Bob, or?
Yeah, two things. Let's see here. Let's have trouble finding the right one here. Let's see if this is it. First of all, there's my first Horsehead that I took.
Nice.
I took.
All right, Bob.
Yeah, took that Sunday with that's the first one I've really processed with a new camera. And
is it a DSLR?
No, it's the ASI 533.
Okay.
Yeah. So this was, and it wasn't the greatest conditions. I was trying to take 120 subs of 90 seconds each. And that was it was going to take about 3.5 hours, or whatever it works out to be.
Your stars are round over the whole picture. Good job.
That's what?
Your stars are round over the whole.
Yeah. I did some deconvolution and some other things. I got this.
I can tell that because there's a dark disk around the two stars down in the lower left.
Yeah.
That's what happens from deconvolution.
Yeah, yeah. And I was going to crop this and not show that, you know, kind of a mistake. But that's whatever that Alden attack or whatever that, you know, super bright star. It's like hard to
Oh
get.
yeah, you're getting some off-axis glow.
Yeah, yeah. And but so here's my issue, and it came up with this, which with that camera, my scope, I could barely see the Horsehead, so I could get it somewhat centered, but I'd like to, okay, let me go to my other image here. I'm trying to do my currently how I've got it set up here. So I've got the red I don't have set up now. So diagrammatically here, if you see the Celestron AVX mount there, you know, 4 ports there. So the way that Celestron wants you to connect, or one of the ways they say their standard way is to connect the hand controller, and then it's got a little USB mini B at the more recent ones do of the AVX mount at the base of the hand controller. And then they want you to, you know, run a plug from that to your laptop. And I was able to do that. I can do that. It's a little odd to connect that. A guy online said, don't do it that way. Use one, he called them the PC ports. I think he means one of these auxiliary ports. But my question is here, I have the guide scope. If you look to the far right there,
Yeah.
I have that running over. So that's running to the laptop, and that's running PhD2. And that works fine. In fact, I just downloaded the newer version of it where you can do a multi-star guiding, which is great. You know, it's like you don't lose it as often. You know, if something obscures one of the stars, I guess it can hang on more. But what I like to do is in SharpCap Pro, you can do plate solving. And so I'd like to be able to do that. And also you can do telescope control, scope control through that. I haven't been able to do that, but my question is here is if you've got one USB lead going into the laptop and PhD2 is doing scope control, and then you've got, well, I'll say another thing, and then you've got SharpCap Pro that potentially has scope control too, because what it does, there was another video guy on YouTube, he had, the third thing is Stellarium. Stellarium would be great to be able to have that hooked up, and then I can just click on something. And so he had his set up with SharpCap Pro, Stellarium, and he clicked on a star, and he said, you can see we can't see it in the camera. And so he said, let's do a plate solve. He did a plate solve, and then SharpCap Pro automatically goes, you know, slews the thing and puts it dead center or very close to dead center. And so my question is there going to be a conflict in the laptop here where you have?
There can be.
Pardon?
There can be.
Yeah. So my question is, I think people have been able to set something like this up, and it's like, how the heck do they do it? That's, you know. And
the
then
softwares have what is known as a hub. Either the PhD guiding or whatever, the commands go into some sort of software widget, and then it controls the different
okay, so
program.
they're doing it through a USB hub. Maybe that's interesting.
There is a software hub.
Software hub. Okay.
It's the command.
Each device
And
should have a
the-
unique identifier that hopefully the commands are routed to that over the USB. But of course, if you're talking about they're both sending guidance signals, they're both sending it to the same device. Never mind.
No, but you're right though. They do have, and that's the way to get them to connect is you have to identify the COM port that they're connecting to. So anyway, this all looks like a little bit like gibberish, but it's like I'm close to getting this to work, and in the back of my mind, I was thinking, so you can also use this other one in the upper left. There's CPWI, the Celestron software that they give you when you buy, a mount or you buy one of their scopes. So I have that, and I can connect that too. I'd kind of prefer to use Stellarium though, because I'm starting to find these features in Stellarium that are just great. The WUT, you guys probably know, it's in the configuration window. You click on one of the options there, and it's called WUT is called What's Up Tonight, and it just shows you a whole everything that's going over your location. I thought, wow, that's great.
Bob, if I'm getting you right, you're saying that there's several programs here or several things that are trying to guide your scope, and you want to know how to set up a hierarchy. So one takes.
He doesn't want two outfielders running for the same fly ball and then they both stop at the same time.
Yeah. So I think all I really have right now, well, I was able to get 2 of them running at once, but not in the way that I wanted to, where I had this CPWI connected through the handset, and then also PhD2 was guiding. Now, obviously, if you're guiding, I wouldn't have it in a guiding mode if I'm slewing around and everything. That's going to throw that off. But I just, there's got to be some way that you can. The main thing is like Stellarium, to have something that's that nice where you can see the whole sky and pick something and just have it slew over to it. And especially, here's the main use of this. If I have a very dim target, and I remember, Jerry, you had said in a previous week that what you did is you just took a very long image of just to see where you were.
Yeah.
And I could do that, but I thought that may take a long time, especially if I'm looking at different images. I just want to have like Stellarium or something, and combined with a plate solve. I just give it an RA DAC.
So Bob, I think what you need is Nina or SGP, one of these things, because SharpCap and PhD2, they are basically some loose units, but there are other packages that are meant to integrate all kinds of functionality, such as a planetarium software and SharpCap, because I've seen a demo online from somebody at the Sky Searchers. It was really cool. He had Nina controlling everything, but he used SharpCap for he also had plate solving on. He used SharpCap for stacking live, so that was pretty impressive actually.
Yeah.
And he also controlled filters and so on, but you need some integration tool, and that's Nina is the free one. SGP, you can pay for that, and I'm using ECOS on the Pi. ECOS is free, but it runs on a Raspberry Pi, so if you don't like Linux, then it's not a good choice.
No, in fact, I'm during the week I downloaded Astroberry, and I'm starting to set up my Raspberry Pi. I haven't loaded it.
Well, that is one of the simplest solutions, really, because it has everything. It has the planetarium. It has a standard autoguider, which I always use. You can also include PhD. It has plate solving, control of your CCD, filter wheel, guide scope, CCD, everything. So
yeah.
It's really easy to get started. I mean, you have to work your way through the menus and so on, but it's actually once you get used to it, it's pretty smooth.
Yeah, my long-term plan is to use that. It's just I know it's going to be a little uphill to get everything set up right, and I've worked so hard to get this to work. I'm like 85% of the way there. I just want to get this to work.
But SharpCap is not a bad idea. I mean, SharpCap, the nice thing about that is that you can use it for polar alignment, which is kind of cool.
Yeah.
And also for live stacking. So what this guy did he had his YouTube live channel on, and we were all looking. And as a result, I've now spent like $4,500 on new astrophotography equipment because I'm going to do it. So, but he was stacking online, so he was also filtering, so he could get more H alpha and that kind of stuff. So it was that was very nice. That's one thing that ECOS does not have. It does not do live stacking. Also with SharpCap, you can edit your image while it is being displayed. That's all pretty impressive. I don't know where else you would get that. So that's an advantage. But for just the basic stuff with plate solving and auto guiding and everything, ECOS is a good solution.
Yeah, I think I had shown this in the past. You can so here I can go folder. Basically, what you're saying here. Let's see here. I'm going to go down to here. Just give me a moment here. So sorry here. I'm going to. Okay, that's not working.
Yeah, and I was also just surfing, just searching for Nina SharpCap and so on. And I found a thread on Cloudy Nights, and they say just let Nina do control PhD too. Don't try to let something else do it. Just Nina. And so because different things can take control if you don't want it. Yeah.
Okay. Yeah. Yeah.
Does it look familiar?
Just about in the last week, I saw Nina. I was looking for some information on that, but I haven't tried, I haven't downloaded or tried anything with it yet.
Yeah. Well, if you want to use that, that's Windows only. So then you need to try Nina, I think.
Yeah.
And
Anyway, it's probably going to take longer than.
It would run smoothly in it. He also had a planetarium program up, and I think it was Stellarium, but I'm not 100% sure. But there are various choices.
Yeah. Let's see here. Anyway, I'm gonna surround it. But anyway, here's what you do. You can do a simulated thing here where you just give it a folder with images and do the live stack here, and then let's see. I don't have one to open, but anyway, you can go straight to this histogram thing that. Well, that's not the one that I wanted. Now nothing's working right. But anyway, what you were talking about the live stack, it is pretty impressive and everything. You don't even have to save the images as you're collecting them, or you can as you're going, and then you can kind of modify them with the stretch, and get some pretty nice looking images. But anyway, I'll get that ready another time and do that. But yeah, I like the SharpCap Pro thing, especially because I keep the telescope set up outside, covered over with tarps and everything, and then I go out and hook everything up, and I do that polar line, and it takes like 5 minutes. I'm close enough to it already, and I just get it down to like 8 to 10 seconds or something like that, and it's great. Less trouble, because I mean, the easier, when I first started getting into this, it hasn't been that long, but somebody said the telescope that's right for you is the one that's easiest for you to set up, that you'll actually use.
The one you find yourself using the most.
Yeah. So I've tried to follow that rule, and how I set this stuff up. So anyway, okay, I'll that's as far as I've made it this week. I'll report next week.
Hey, Bob, one thing about Stellarium. How do you make it such when you bring it up, it doesn't cover the entire screen?
Oh, here, I'll show you that. I've actually got it up right now. So yeah, a lot of times you don't have in this upper right corner, you don't have the minimize thing here. So if you move your cursor down to the bottom, and now something else comes up, and you click on these 4 arrows pointing towards the center,
So
that will make it. Then you can reduce it in size, or minimize
good.
if you want. Yeah, there are a bunch of.
I need multiple things up at once. I got the laptop.
Yeah. Here's that thing I was telling you about, that what's up tonight thing here. Let's see, what is that? So you say you want like bright nebula or something. So that just gives you, magnitude, and it'll organize by magnitude if you want. Which is just kind of a neat little thing. I just discovered this last week. You go through this list of everything it's got. So anyway, that's that.
Is Stellarium only Mac only, or is it?
Oh no, it's on
Windows.
the PC.
Okay.
Cell phone also, I think.
Yeah, and it's free.
Yeah, I knew it was
Cell phone,
free.
you have to pay for it a cell phone.
Oh, okay, yeah.
Smartphone. So Tim, were you working on your mirror this week at all?
No, I'm gotta admit, I've been super lazy. I've been really struggling with the project in this guitar project, and it's absolutely destroying me. But I'm at a point where I don't want to do any more figuring right now. I want to set up the knife edge. I want to do the knife edge with it, and I think I'm going to have to set up at night. Tonight's a really bad night because my wife got like 1 hour of sleep last night, and so what I want to do is get it really dark, be able to turn the lights on and off, and then get a good knife edge test going. It seemed to me that with the Ronchi tester that I have, which is pretty Mickey Mouse, I've set it up so that I have 2 different LED light sources. One that's in the viewing window that I used with the Ronchi, and another one that's below it's really built the way that the Stellarium plans had it, so that the light source is below the window. It reflects up to the mirror, back through the window where your knife edge is. And what I remember is that when you're doing the knife edge readings using the pinstick, that dimmer light source with a really, really refined slit was easier to read than a real bright LED. So I want to play with that a while. I don't have the ability to do what Mike's done and what Bruce was trying to teach me with XL, is setting up a program so that I could actually write my own program and do the testing and have that graph. I use a program that's done by a guy named Rifke, and it's gone now. I don't know what happened to the guy, but I think it was called Foucault Test 2.2a. And so I kind of heavily rely on that, even though I don't know what the sources, what's the word for that? I always forget that word, but what the equations he's using in there, I don't exactly know what it is. But I did my 10-inch using that program. And what I intend on doing is taking several lines, of that, and doing them all, and then averaging them out. And then I'll show you the result of that on a graph that this Rifke program has. Yeah, so you can see where I'm at right now. I just don't want to mess with it. I know if I mess with it, I'll do what I did before, and then I'll get further away. I do believe I need a little bit more figuring, but I want to stop and do some testing first. I think it's good. So that's kind of where I'm at. And the reason for my dragging my feet is because I'm doing with this guitar project. What happens is that you do glue ups with guitar parts that are too far for you to reach with clamps. So they make a thing called a go bar deck, and it's just two different pieces of plywood or MDF, pressed board, and then you put that together with rods that you can the upper plate you can lower or raise so that you can actually bend these fiberglass rods over the project you're using. And when you glue something to the surface of your guitar, you bend the rods in and then just set them on top of whatever you're doing. I'm gluing braces in to the top of a guitar, the inside of the top. But every time I've done something on this project, it's blown up. And the last iteration I did, I used these little plywood rounds that these 1/2-inch aluminum rods would slip through. And I got everything set up, and I put the little fiberglass rods and bend them in and set them on top of the braces, and everything was fine. And all of a sudden the pressure just of those rods actually pulled apart the plies and the plywood. So I was kind of blown away by that. I thought the plywood is a lot stronger, but apparently it's not. So that's why I've been dragging my feet on this telescope project. I keep running into this thing and it's driving me crazy. So maybe I'll take a break and do some telescope stuff.
Sounds to me like you developed a turn down edge on your guitar.
Yeah, exactly. Well, the one good thing is I think I don't have a turned edge anymore. I think it's a pretty good. I think it's.
Yeah, I saw your edge recently, and it's very good.
Yeah, I think what I need to do is just kind of do what you were recommending, Jerry. It's just to start taking some data, and that's what I want to do. But in this house, which is all I've got to do the testing, it's kind of right in the middle of a well-trafficked room. So I have to kind of wait till everybody's still and I can block the light out. And like I said, the best results I've had is when it's really dim. So I have to kind of wait for this time of the night and set the whole thing up and take several measurements. And then I'll plug them into that program and see what I get. And then I'll send a couple of the diagrams to Tom and let you show him, what I get. I'll try and do that next week.
Okay.
Hey, Tim, I just saw on stellafane.org website, and I put it in the chat. There's a link to some software for Foco data
Rifty.
reduction software. And it says one of the software is a Foco test analysis or Foco test analysis by Andreas Refke. And it's good through Windows XP through Windows 10. And you can download that software.
Tom, I sent that to them.
Really?
Yeah, I got in touch with Stellarium guys and I talked to them and I said, look, you know, that this guy, Andreas Refke, wrote a really good program. And they said, we know, but we can't find it online. We don't have any of it. And I said, well, guess what? I've got the only version I saw that's really his latest version, which was 2A. And you'll see on that website, that's what it is. And the other one was 2B. It was a beta version, which wasn't as good. This 2A it's a really good version. And what's great about it is if you're using pinsticks, imagine your center line of your mirror, and then you're going to be using so many pins to the right or the left, you know, and say you want to use 3 pins, let's say 4. So you're going to have 4 out to the right, 4 out to the left. And when I sat down with Tom Whittemore, he showed me mathematically, and you guys are so above me on that, but what you want to do is you want to find the location of those pins in inches or in millimeters, whatever. You want to find out the 10, 10, 20, 30, 40, like say 40, and then 50, 60, 70, 80 out to the 100 zone. And then all these different pins are going to fall over one of those zones. And those are mathematically positioned. When Rifke's program, if you just kind of like put the cursor over it and go, okay, I want 4 pins, and you click it, these suggested pins come out. But when you use Tom's and Jerry's and everybody that you guys in the workshop, when you use those measurements that you guys mathematically get, you know, they're different. And what you can do with what you can do with the pins in the Rifke program is you can just like take them out and put in your own pin settings, and the program accepts it. So that's what's really nice about it. You can use the pins that we get in the lab that are in the workshop that we use. And when you plug those in, the results come back and they're really nice. I think what I was telling you guys, the only downside of this Rifke program that I do not like is that when you get to the inside zones, when you get closer to that center pin or into the 40 zone area, that's the first pin you see in this picture near the center. When you get into that 40 zone, when you're trying to put that little donut over that pin, it's really, really hard to see it. It's just so dim that you can't discern it. And so you're kind of guessing. Sometimes Tom would take his finger and kind of tap the tester. And if anything moved, he'd say, there it is. You know, or you use averted vision, just like we do out in the sky, night sky. But seeing that last pin on the inside is really, really difficult. And in this Rifke program, if you take a guess at it and you put it in and it's wrong, the results of the wavefront come back really off. And so what I did is, again, Tom Whittemore, who's been such a good mentor for me, he sat down and showed me that mathematically the difference between one pin to the next when your parabola is right, it's something like 0.017. And so what I did is I plugged in the right number for that inner zone, which is supposed to be proper. And when I did that, the wavefront came out like looking as close to what I think it would be. And as soon as you get away from that, try to guess at it, you don't even know what you have. So it's a downside to that program. What Mike did with his, and I think it's an Excel program. You know, he knew the equations he was using in it, and so when he took those measurements, I don't know, Mike, what do you think? You took those measurements, and did it make a difference if you were really accurate on that 40 zone or not? Did it throw it way off?
Well, I chose a different number of zones simply because my mirror was so much bigger and faster. So instead of using like the 3 or 4, possibly 5, you know, I did like 8 or 9 zones just because it was a big, fast mirror.
Yeah.
And so the mathematics work out that, you know, on the pin sticks, you find out where the zones are
Oh, yeah.
supposed to be, and it gives you the reading.
Yeah. So I think the word I'm looking for is the algorithm. I think I was talking to Chuck one night. He said, if you don't know what algorithm is being used in the program you're using, you really can't trust your results. And that's why I sat down with Bruce for a couple of weeks at the workshop, and he tried to show me how to use that Excel program. And he actually wrote one out for me, but I haven't done it yet. I just haven't done it.
Okay.
The last thing I'll say about this is that I was taking a look at the scope that I built to put this mirror in, and it's just literally waiting for me to put that mirror into it and go out and do a star test. And I see already refinements that need to be made on that. For instance, the laminate that we're using now, rather than, I think, what was it called? Was it Starry Night, or can't remember. The best laminate you could use is no longer there. So I think there's one that was recommended by Astro Systems guy. It's called Lunar Mist or something like that. But there's no real good Teflon laminate glides anymore that really gives you that perfect stiction. And that's a downside to what I've got, as well as the actual bearings themselves. It looks like those bearings are real sloppy. They're going to just want to wobble right off the scope. As much as I took care to try to rid it of that. But other than that, I'm just waiting to get a couple of these numbers, get as close as I can, get that sucker out and get it illuminized so I can get it out and take a look at it.
So you guys notice in the chat box that I put three things. So the Mars 2020 this Thursday at noon. So we got to make sure we tune in and see, get the delayed information, whether it crashed or not. And there's a donated telescope that we just got in, and that looks like be a real nice C8 system using the pre-AVX mount, but the CG5 mount for Celestron. Should be in very good condition. And then Bob, next Tuesday, we'll have Bob give us probably 45 minutes of his astrophotography on doing the planets and the moon. So look forward to that next Tuesday.
Okay.
Oh yeah, that's the one, the Foucault 20A. That was it. Yeah, that's the one I gave him.
Okay, he's looking at the stellafane.org website there.
Yeah. I'm looking forward to Bob's presentation. That scope. Does the museum still have, to your knowledge, you guys, do they still have any other scopes real cheap that we can purchase? Should I just get in touch with Art on that?
I'm not sure what Art has.
The museum doesn't have any scopes. Those are all ours.
Well, I think Tim means in the shed.
Oh, okay.
Right.
I have a C8 sitting in the garage.
That
So
came
my-
with Edgar.
And I think we have a couple that are in the shed.
Okay.
I've got
Well,
one
I
I
didn't-
could donate to, a 4.5 inch Meade Newtonian.
Oh yeah.
Yeah, older.
4.5 inch.
Yeah, it's one of these ones from Costco. Years and years. Yeah. But
My sister has a guy that's actually living on her property that insists on getting a telescope. And when I mentioned like a C8, she goes, "Oh no, it's good." It's the more I get the idea, it's going to have to be something that's kind of a no-brainer, probably refractor the better. And this guy's in Sacramento, and Mike knows what I'm talking about. There is no sky in Sacramento. There's none. I mean, on a good night, you can go out and really look hard, and maybe you might see Orion. But
That's
it's
because the air that's because the air's got a lot of stuff in it.
Yeah, it's heavily polluted.
it's terrible. I took up my Televue up there, the 4-inch Televue, and took it out in the back, and I said, "Let me just show you guys this stuff." And I looked up and I went, "Wow, that's it for the night." You know,
Maybe they want the telescope to look at their neighbors. They don't want to look at the sky.
you know what?
They
That's a
go to
good
the
point.
Sierras.
That's a good point. This guy that lives on your property is really, I'll tell you guys about it sometime, but
Yeah.
it's a real story.
Well, I think I'm out of time here, so I'll see you guys all next week.
Hey, Chuck,
Hey,
bet, Gary.
Chuck McPartland, does Edgar, do you have a price on his scope that you want to sell the C8 for, or
Nope.
about $400 or something probably?
Yeah. It's a C8 Super from like 1982 or something like that. It's got the Byers worm gear drive.
Huh. And he's selling that?
Those are good worms, good drive.
Yeah. It does have, I know he managed to, I think, cross thread one of the collimation screws. So it might need a little work there.
Well, these guys aren't going to be collimating, I'll tell you that for sure. They don't even know what that meant. So, you know, it's a thought though. I'll mention it to him, Chuck. I'll mention it to him. And did you show these guys the thing that Edgar sent today on the email?
No, I didn't.
That was pretty cool. Maybe I'll get that and forward it to everybody I know here. I don't know Rob so much, but hi Rob, I'm Tim. but you know, I'll try to remember to send it out. It's pretty funny.
You mean the Pfizer thing?
Huh?
The Pfizer thing?
Yeah, I'll just tell you guys, it was a video that Edgar sent out, and it was a guy on Valentine's Day that got down on his knees and to his girlfriend, he said, "It's what every woman wants," and he opens the box, and it's a COVID-19 vaccine. and then he says, "Yes, every woman wants one of these," you know. And then it shows her with the hypodermic in her arm, you know. And then the final word was, "It's available nowhere."
Yeah.
so it's pretty good. If we can't get them, we might as well laugh about it.
Yeah.
I got vaccinated.
Good job.
Yeah, I'll just say it again. I think there were only 3 of us on at the end of the last week's meeting, but there's a senior home behind me, and I know the guy, the manager, and he said, "Hey, I got 5 seniors here and 6 vaccinations, so come on over and you can get vaccinated."
You
So
got one, Bob?
I got it. I got my second one on March 1st. They actually booked me for a second one, so I'm not old enough or anything, but they gave it to me. So
well,
great.
The coup de grace for me is when Jerry, who's gone now, see, you know, Jerry's what, 80? And
he's 75, maybe.
He's 75. Anyway, doesn't matter. The guy, his first vaccine was scheduled in June. And I was going, what is wrong? My wife complains about it bitterly. She goes, Santa Barbara is getting like 20,000 doses. Ventura, 40,000. It doesn't matter when you look. They get twice what we get. And it doesn't matter when you look.
People were going down to Dodger Stadium, registering from Santa Barbara, which you're not supposed to be able to do.
Yeah.
Going down to Dodger Stadium, but they were doing it. They were accepting it. So,
Huh.
but I think Dodger Stadium ran out too. So
Yeah.
The last
friend-
thing
The supply is weird.
yeah.
the last thing I'm gonna leave everybody, but I'm gonna leave it on one note is that my son Jason he's constantly looking on the web for different things, and he said there's something in vitamin D3, and I can't remember the name of the actual product, the drug, and it's they say that it prevents like 80% of getting to an ICU, 60% of getting, you know, it being fatal. So whatever's in vitamin D3, take it. It supposedly really helps to deter. So that's just something he took a look at.
Or stand out in the sun.
Yeah.
Or stand out in the sun. I do that a lot, so I'll be
It
fine.
seems to help with the respiratory effects, but I don't think the effects are that big.
Yeah. So whatever the drug in it was, it's usually used for people that are suffering from like kidney failure, for kidney disease. And so that's whatever it was that they were using, that's the element that was in it. I looked at, trying to get some from a drug company. It was like, oh, come on. It was whatever the amount was. It was like a thimbleful for $250. I went, nah, I'll wait for the vaccine.
Yeah.
You know, I'll get it
There's
next
always-
year.
There's always medical marijuana. So
Yeah.
Yeah.
Oh, you know what? Did you see that marijuana dispensary workers have been classed as medical workers, and so they're on the list for vaccination?
Well, my sister called me. Sometimes I really get upset by people trying to finagle their way in, and I'm not saying Bob, I'm not saying you. The guy asked you, but you know this. My sister calls me up. She says, "Well, you're a dental technician. You should be able to go get one." And I said, "Carol, I'm retired." They said, "Well, they don't know that." And I'm going, "No, that's just not the way it's supposed to work." You know, there's a lot of people out there that really could use it. So, you know, whatever it's worth.
I
So, you
just
know,
think it's so hard to get an appointment, and I can just stay home and not have to worry that much, you know, that I'll
Yeah,
let
I'm
the
lucky
people
too.
that really need it go, and the supply chain should get better.
Yeah, my only real fear is going to the grocery store, and then I play tennis a lot. But I play tennis with my son, so we're really a closed little community down there.
Tim,
But,
we use Instacart to go shopping for us at both Costco and Sprouts, and you pay
Oh.
a service fee, and you know it's like you can drive there and get in an accident, so you might consider Instacart cost as being insurance.
Yeah, exactly.
So, yeah.
Exactly. I heard you have to kind of pay them heavy to get if you don't give them a big enough tip that they'll deliver it maybe next month.
We give them like, you know, on a $130 order, we gave them like $13, a 10% tip, and they get
Really?
they get a salary and hourly or whatever. So it's kind of neat.
That's all right. Yeah,
It's just,
my
only
son was
dealing-
telling me that if you buy something for $10, you better tip them 25, or you won't get it. Anyway, guys,
All right.
it's been nice
That's
again.
good. Nice meeting. Hope to see it. Everybody tune in Thursday for Mars and see if we crash, and then next Tuesday we'll see you for Bob's talk.
No crashing.
Ta-ta.
Okay.
Okay, bye everybody.
Right.
Everybody.
Bye.
Right.